Okay, the review that we're doing today is going to be a little bit different than we normally do. I'm not going to be doing writing on things because I'm at home trying to do this via computer. So you're going to have to pay close attention today or you may miss something. So let's get down to business here. All right, we're going to state whether these functions are going to be growth or decay. Then we're going to give the Y-intercept and we're going to do the end behavior. We can do all this in the calculator with a little bit of our brain here. So for instance here, which one's it going to be growth or decay? Be careful, remember, we're looking at our b value. Our b value, even though it looks like a fraction, if I punch it into the calculator, would be 2.5 if you hit 5 divided by 2. So this one is going to be growth. Okay, so we've got that part. My y-intercept basically is just going to be, since there's no left or right shifts going on, it's going to be my a value. And again, the a value would be the number that's in front of what I'm taking to the x power. So in this case, that would be 0, 3. Now, is it possible that if you happen to forget that, you could do it on the calculator? It sure is. So what we're going to do, if we're going to go that route, is I'd go ahead, I'd type it in here. So I've got my 3, I've got my 5 halves to the x power, and I could go ahead and pull up my chart, and wherever x is 0, that y value is my y-intercept, so it's a 0, 3. So I could do it that way too if I really wanted to. Domain and range. Now again, here we're just going to talk about it for a second because this one's a little harder to do when I'm not writing. Alright, it's like through the power of magic we've made a quick change here on some things to kind of get us up to date on some stuff. Again, we've talked about that it's growth because of the 5 halves. We talked about the y-intercept being 0, 3 because of your a value. Now, domain and range, since there are no shifts, my domain and range for these is going to be the same. Domain, we mentioned before, is always from negative infinity to infinity. And my range, when there's no shifts, you'll notice it goes up forever for positive infinity. But you notice it starts to tail off when it gets to the x-axis, which has a y value of 0. So my range is going to be 0 to infinity. Now, the only thing I'd have left on this problem to figure out then would be the end behavior. So again, when I'm doing that, we've talked before about how domain goes along with my x values. So there's the negative infinity and infinity. The end behavior for f of x or y, though, goes with my range values. So one of these is going to be 0 and the other one's going to be infinity. It's just my job to figure it out. So you can do this a couple of ways. You could just say, well, it's going to infinity is it's going to the right. Well, the right is positive infinity because my x values are getting bigger. So on this one, when I was going to figure this out, I'd actually go to the one that's going to infinity, and that's where I would put my infinity symbol. Okay, so as we're doing this, and again, a little different than it normally is, because, well, we've got some different circumstances rolling here. We'd get that in there, and then the other one would be my 0. And the reason for that, again, as I take a peek is, as I go to the left, as I head towards negative infinity, it heads to 0. So the only difference that we're going to see between numbers 1 and 2 is initially we may think that number 2 is decay, because I see that it's, between 0 and 1. But this is one of those times that maybe, just maybe, double checking it on the calculator might be a good idea. So, let's go in here. So as I get this typed in, I notice that it is a negative x for an exponent. And usually when we have negative x, it looks like growth. What the heck? Oh yeah, that negative x, okay, that's right here, is going to make this act like it's 4 to the 2 over 1, or 2 to the x power. So when I'm doing this, it makes it act like that it's 4 times 2 to the positive x. So this is still going to be growth. Now, again, you've got to keep an eye out for that because that can happen to you. My y-intercept, even though it's switched on me, doesn't change at all. That's still going to end up being 0, 4, because again, I just look at my a value when there's not a shift. And then my domain and range, since it's another growth problem, actually end up being exactly the same. There's no shifts, there's no movement. Now, I do have to keep an eye out for my end behavior. So I've got my graph of this one already. And I look and I'm like, hey, that looks a lot like the last one. It's going down to the left. Or in other words, towards where 0 would be going to the left. And it's going up forever as it goes to the right. So actually, your end behavior would be exactly the same as it was in number. So it would look like that, and then we'd be ready to move on to the next part. But again, I would say probably except for end behavior, you could do all of this without the graphing calculator. But again, if you play with it a little, it's not going to be anything that's too bad for you. Okay, so then we get down to graphing the function. Now, we don't do anything too cute or fancy here. We're basically going to let the calculator do a lot of the work for us. And I'm actually going to be doing all of the work on the calculator. You will not be seeing graphs on the left side of this screen. So you actually need to either punch this in your calculator or be paying very close attention to the number values that we have as we're doing this particular one. There is a worked out key in the front if you want to look at some stuff in there instead. But this should help you get an idea because you should be doing all this punching on the calculator yourself. Notice no parentheses up here with my x minus 2. The minus 2 is not up here in my exponent, so I leave it alone down here. So I take a peek. I notice that since it went which direction to? Yeah, since it's not in the exponent, down to, that my graph shifted down to. So let's look at our chart here. And I'm looking basically for some whole numbers to use, or maybe some bigger numbers. I mean, maybe that 5.59, I just go, -5 and a little above 5 here, and I put a dot. I'm not going to be able to use just whole numbers on this one. It looks like I'm going to have to go a little deeper. But just plot several of the points on here. Make sure that you've got everything set and that you don't go below -2. Because notice we're getting real close to that value, but we're never passing it. So when you're graphing it, as long as you're seeing that downward motion, then maybe we make sure we got a point here at 0, -1 down here. And that you've got your curve rolling. It looks a lot like this one. Okay, my domain is still going to be the same. It's going to be the same forever on these. So up here we look again. Oh yeah, domain was -infinity to infinity. So now I come down here, it's going to be the same, but my range, since up here, we move down to, okay, so does my range. So my range now, instead of being 0 to infinity, is going to be -2 to infinity. That's the only time my range moves is if there's an up or down shift. So it's something to keep in mind. So then I get to number 4. Now again, before I start graphing it, I should be able to figure out the domain and range part. The domain's still -infinity to infinity, just like it always is, because it goes forever to the left and forever to the right. But this time, my shift, that -4 that's up there in my exponent, what's that stand for? That would be a right 4 shift or transformation, not an up or down. So my range is still going to stay at 0 to infinity. But let's take a look and see why that is. We'll go get this one typed in. So as we're doing this time, since my exponent has the shift, the plus or minus, I need to make sure I use parentheses up there. If I don't, I'm not going to get the right answer. It's going to be more like a down 4 shift. So if I look at my graph, I notice it moved to the right when it started, but it's not going below the x-axis. It's not going below where y equals 0. So domain, -infinity to infinity, range, 0 to infinity, just like it was in number 1 and number 2. Okay, and that's it for that. So I get down to 5. Okay, if f of x is 7 to the x and g of x is 7 to the x minus 3 plus 2, explain how to obtain g of x from f of x. What is the transformation, or in this case, transformations? What are the shifts? If you're just looking at this, okay, what are your, whoa, look out, we took off. What are your two shifts going to be? What's the -3 stand for? Right 3, just like up in the one above just before this, it was right 4. And then the +2, since it's not in the parentheses, or not in my exponent, is up 2. That's all I need. All we're going to do for that one. 6, I'm going to do a little adjusting here. On yours, it might be on this front page, but on mine, so I'll go to the next part. So the amount of a radioactive isotope decreases 4.5% per year. If the sample originated with 245 grams, determine how many grams of the isotope remain after 15 years. Okay, my A value is what I'm starting with. Okay, so this 245 is going to be my A value, what I'm starting with. Okay, since it decreases at 4.5% per year, okay, that's going to be minus. So just to recap here, our A was 245. Our rate, remember, is turning that 4.5% into a decimal. If you don't know how to do that, just do 4.5 divided by 100 in your calculator. You'll get 0.045. And again, I remember with decreases that I have to use the subtracting. So when I go to put this in, it's going to look a little something like this. So there's my finished equation, my starting, and then my 1 minus my rate to time. Now, the amount after 15 years, since there's only one question here, I don't really need to put this into the y equals part. I could. Okay, all my y equals and end up being the same. But if I'm going to go this route, I just as easily could get out of here and just do 245. 1 minus 0.045. I use x since t is not available. But again, wait, you're like, wait, why am I using x? I know how many years. It's 15. So I can just type that value in. Now, if you did do it in y equals and you put it to the x, you just scroll down to 15. That would work too. So hit enter. It looks like we're going to have about $122.81 working here. Oh my gosh, I'm sitting here turning into money and we're talking about isotopes. What am I doing? 122.81 grams remaining is what I would be looking for there. Definitely not dollars. We're not talking about dollars and cents yet. So that's how that would work. But again, y equals with an x and scrolling down to 15 would absolutely work as well. Okay, 7 is going to be similar. The city's population is currently 45,600 people, but it grows at a rate of 2.3% per year. Write an equation to represent the city's population. Then calculate how many years will pass before the population reaches 60,000. Use your calculator's table function or graph. Well, we will absolutely use its table function. So let's see what we got here. We know what we started with. We have our A value, which is 45,600. And it says it grows. So 1 plus my rate is 0.023. Again, you got to turn it into its decimal form. And then we would take that to the x. That is my A. Right here. Okay. So again, we'll take a moment to get this put over in our A slot. So there's my equation, 45.6, 1 plus 0.023 to the t. When will the population reach 60,000? Okay. Now this time, since I don't have a number of years, I'm trying to figure that out. I go to my chart. And I start scrolling down until I get to 60,000. Once I hit that year that's over 60, x is 13, so about 13 years, and I'm content with that. That's all I need. Okay, 8. You invest part of your summer income in an account that collects 4% interest continuously. How long will it take for the account balance to triple? Use your calculator's function or graph. A equals PE. E is a number on your calculator, again, to get E. You're going to hit second in the ln, or the natural log button, and that'll get E, and it'll automatically make it an exponent for you. So we have to make an equation, though. Now, one thing I noticed is it says part of your summer income, but it never tells you how much. This is one of those problems where you can figure out what you want your P to be. $100, $10, a penny, $1 million, doesn't matter. I'm going to use 1,000 because that's just normally what I do. So I'm going to go ahead. Okay, 1,000 is going to be my P. My E is just going to be that value. And I'll do this on the calculator in just a minute. And then I've got my rate at 0.04 times time. So now you may be asking at this point, okay, so I see where the E comes from, the 0.04, the T, because we don't know the time, we're figuring that out. Where'd you get 3,000 from? So I come back up here. How long will it take for the account balance to triple? So if I started with 1,000, 3,000 would be the triple. If I would have started with 100, 300 would be the triple, and so on. But I have to have that part, because here's what I'm going to do now. I'll bust out my calculator. I'm going to go ahead. I'm going to type in what's on the right side of my equation, part where the 1,000 is at. So 1,000, E again, which is second, ln, 0.04. Again, I don't have a T key for this, so I'll use X. And then I just do second graph and start looking at my chart until I get to the year that 3,000 gets hit, which would be 28, no, not year, but 28 years. And again, we're just kind of semi-approximating. Once you see that magic number show up in the right-hand column, that's when you get to stop. Okay, but again, I'll tell you the equation, so use the equations that are given. Okay, suppose we invest $1,200 in an account paying 5% interest compounded monthly, finding the account balance after 9 years. Okay, this time it looks like we need some more info. So, go ahead and make ourselves a little room here. So my P again is my principal, which would be $1,200. My rate again is that percentage as a decimal, 0.05. Compounded, ooh, there's the magic word, compounded, monthly. How often does monthly occur in a year? It occurs 12 times, so that would be my end value. And then find the balance after 9 years. So I have all the numbers this time. Again, I don't have to go to y equals, but I could. So what I'm going to do is I'm going to go ahead. I'm going to get this punched into the calculator. So let's do that. Okay, so for the A equals part, and I'll have that up here in just a minute. It'll just miraculously appear. So we're going to go ahead, and we've got our principal, 1,200, 1 plus my rate, 0.05, divided by my end value, 12. And then we're going to take that to the n times t. Okay? That's what it looks like, whether I put it in the y equals or the regular part. So it's kind of interesting that I chose to do it this way this time, and I'll show you why. Again, if you weren't seeing it before, our A equation has miraculously shown up here. But now back to what we were talking about. Okay, well, what if I put it in the calculator? Because if I hit the second graph now, all the numbers are the same, like no matter what. What the freak's up with that? Okay, remember, we put a number in this time for our t. So it's not going to be different, but I'm getting the right answer all the way down. Okay, and again, I'm not going to go and gripe because that looks like 1880/20. Now, if I took a little closer of a look, or if I'd have done it in another spot, okay, not in y equals, notice it really is like 22 cents, and I'll put that in here. But if you put 1880/20 on the quiz, I'm not going to mark it against you, okay? Because I know that you were just looking for y equals chart. So that would be okay. Okay, not bad so far. Shoot, we're already at the last question? Yeah. Okay, we're trying to decide which apartment to rent. Choice A charges $300 a month, but the cost increased $20 a month. Choice B contract charges $200 a month, will increase 4% per month. Which apartment is more economical? Okay, here's your first job. You need to come up with an equation for each of these. So I noticed on choice A, it cost me $300 a month, but then it's going to be going up $20 every month. So we could call that 20x. So then maybe we go and we say, okay, so what's this next equation going to be then? Well, the next one only charges you $200, but they're going to increase 4% per month. So, now this is the one that gets a little trickier, because I can't just do plus 0.04x, okay, because that wouldn't multiply it times 200. So I have to use my growth part of this, so stick with me. We've got 200. Actually, let's make this even easier. Why am I making this difficult? You're like, why are you, Harty? I didn't mean to. Because I could just have my principal, and I could use my growth formula. 1 plus 0.04 to the x power. So I've got these two equations now, and what I can do is I can use my graphing calculator to compare them. I mean, I could try to do this in my head, but that would be the hard part, would be trying to explain what you're doing without having any data to work with. So let's go ahead. We're going to type both of these in at once, and then we're going to do a little compare and contrast here. Oops, probably should do my plus in there. I'm getting a little ahead of myself. Actually, how this makes me slow down a little bit, right? Okay, so let's compare. Get back to 0 here. So I look at this and I start to scroll down, and I'm like, shoot, choice B looks a lot better of an option. Holy cow, man, it's not even close. That's kind of crazy. So I'm starting to look like I haven't seen any place here in a long time where the second column ends up being bigger than the first. I mean, is that ever going to happen? I mean, I start to go down. And again, think about this. This is monthly. So, I mean, okay, I just passed 2 years. I just passed 3 years. I just passed 4 years. You're like, ooh, it finally went past. Yeah, it finally went past right here. 47, almost 4 years. So which thing do you think is better? Well, I mean, this is just me. Personally, I would stay in apartment B unless $47 months it was cheaper. Yeah, it was cheaper until the 47th month. Now, if I'm going to stay longer than 4 years, maybe you like where you're at. Maybe you're in a big city or something like that. So if you want to stay more than 4 years, then A is the better option. Now, do you have to take both sides? No. But you do need to make a mathematical argument for why, not just it's cheaper, it's 200 versus 300. I want to know that you actually put a little bit of thought into this. Okay, I hope this worked out pretty decently for you. Again, it's a lot of the concepts that we've done before, so you could go back and watch a video on some of those things, check the key up front, ask some questions. We'll have some time tomorrow at the start of class to be able to answer any questions or go over a couple of things more if we need to. So, good luck, study hard.